Today we'll be looking at solving quadratic equations by graphing. So we know that a quadratic forms a shape that we call a parabola. So we're going to look at how to graph parabolas, some simple tricks, and then understand how we can solve an equation by looking at the graph. So when you are solving a function y equals ax squared plus bx plus c, notice we keep that in standard form with the coefficients a, b, and c. That's consistent with what we've been doing before. We're going to set the equation equal to 0 and then find the values of x that make that true, and those are called the roots. To find the roots, we're finding the zeros of the quadratic function. So roots and zeros we often use interchangeably. The zeros are the x-intercept of its graph. So in other words, if you have a parabola, if it crosses the x-axis, wherever it crosses, those are considered the zeros, or x-intercepts. Those are the roots of your equation, y equals ax squared plus bx plus c. So let's take a look at a parabola. I call this the anatomy of a parabola. These are different parts that make up a parabola that help us in order to graph it. First of all, you'll notice that we have a line of symmetry. And the line of symmetry is this dotted line, and the idea is that you can reflect the parabola over this line and you'll get identical pieces on either side. I don't really like the way that's shaped up, but you get the idea that it is shaped over that middle line. There, I'm going to try to draw it again. There. Okay, that's better. The vertex is the maximum or minimum point of the parabola. In other words, the vertex is where the parabola changes direction. So it's coming down and then it changes direction and goes back up again. So that vertex is the changing direction point. The zeros, as I mentioned before, are located where the parabola crosses the axis. So if we want to graph a parabola, if we can figure out where the line of symmetry is, and then we can figure out where the vertex is, and we can figure out the zeros, then we have 3 points and we can plot it. And then we'll often pick up another couple points and go ahead and graph the whole function. So a parabola might have 0, 1, or 2 roots. The 0 root solution would look like this. And as we talked a little bit about this, you're going to get solutions that are complex when you have a parabola that looks like this one. You might have one solution, which is where the parabola kisses the axis in one location, and then you could have a place where the parabola crosses in 2 locations. Notice parabolas can go open up or they can open down, and we'll talk about how those graphs are different soon. So if we want to graph a quadratic function, we want to first locate the line of symmetry in the vertex, find any zeros, and then plot some additional points. So let's take you through an example. First of all, it's good to know that the line of symmetry, and I'm not proving it here, but you can trust me on this, and it's in the textbook, is the value of x where you have negative b over 2a. Again, remembering this y equals ax squared plus bx plus c function down here, that's where you're going to get your a and your b values. So it turns out the line of symmetry is just minus b over 2a. And once you find that value for x, once you find that value for x, you can plug that value into your function here and get y. And that will give you this coordinate point of your vertex. Knowing on the line of symmetry that's the x value, then the y value, plug it into your function and get it. This will make more sense when I do an example for you here in just a minute. Okay, so let's try it. Once we plot our points, we can plug in zeros for x and zeros for y, and that'll help us get a couple points. Apply the x value for our line of symmetry, and that'll give us a point. And then we can just pick some random points that seem practical and useful. And again, as I give you an example, you'll see what I mean. So let's go ahead and try one. Okay, first problem. Y equals minus x squared plus 6x minus 9. We want to now find and graph this equation. So first we want to find the line of symmetry. Let's remember that the line of symmetry is minus b over 2a. And for this function, a is negative 1, b is 6. So our line is x equals negative 6 over negative 2 times 1, which is 3. So that will be the x value for our line of symmetry. So we can go ahead and plot that on our graph, I put a dotted line in there for the line of symmetry. Now let's figure out where the vertex is. Where's that place where it changes direction? So knowing the line of symmetry location is x equals 3, we just take that value of x equals 3 and we plug it into our function. So that minus x squared plus 6x minus 9. That will tell us what the y value is. So we plug 3 in for x and solve for y. We're going to get y is negative 3 squared plus 6 times 3 minus 9. Now, it's really important when you want to solve this to remember order of operations, which say that you evaluate the exponent first. So it's not negative 3 quantity squared, it's 3 squared and then the minus of that. So let's do our 3 squared first. We're going to get y equals negative 9 plus 18 minus 9, which is going to give us 0. So now we know the vertex point. The x value is 3, and we just solved to find the y value of 0. So we can plot that on our graph, and we did with the little red dot, 3, 0. So that is our vertex. Now we don't know yet, is our parabola going to open up or is it going to open down? So let's try to find the zeros. To find the zeros, we set y equal to 0, and then we solve the equation. Okay, so we can solve it by factoring. In this case, I'm going to change it around slightly so that I don't have a negative for my x squared. I can factor it and find that x minus 3 times x minus 3 equals 0, so x equals 3. So that is where it crosses the axis. But of course I already knew that because my vertex point was on the axis. So we now know that this is going to be a parabola with one solution. We don't know yet if it's going to open up or if it's going to open down. So we can just start plotting some points. So let's try the first 2 points of x equals 0 and y equals 0 and see what we get. So x equals 0, when we plug that in, we're going to get 0 plus 0 is negative 9. Now again, what I'm doing is I'm just taking 0 and I'm plugging it into this function over here to see what we get. So I'm going to take different points, plug them in for x, and see what I get for y. I already knew that when we plugged in 0 for y, we got 3. We figured that one out. So let's plug some other points in. I want to find some points that are close to 3. So I'm going to just plug in 1 for x and see what I get. When I plug in 1 for x, I get negative 1 squared plus 6 minus 9. Negative 1 plus 6 is 5. 5 minus 9 is negative 4. So that becomes a point that I can plot. So I go 1, negative 4. And I plotted that on my graph. So you see the 1 over negative 4 down. By the way, I plotted the 0, negative 9, but it kind of went off my graph, so that's why I put that little down arrow. It's not fitting too well. So I'm going to find a couple other points. So the next one I'm going to do is 2. When I plug in 2, I get negative 4 plus 12 minus 9. Again, I plugged in x equals 2, and I plugged it into my function over here to see what I get. Negative 4 plus 12 minus 9. If I add that up, I'm going to get 8 minus 9, which is negative 1. And now I can plot that point, 2, negative 1. All right, so my little green dot appears. Now I'm going to try to find a point that is just slightly to the right of my vertex and see what I get. So I'm going to pick, if that's x equals 3, I'm going to pick x equals 4 and plug that into my function. I get negative 16 plus 24 minus 9. When I work that out, I get negative 1. So there's another point I can plot. I'm going to go, just for symmetry's sake, another point and plug in x equals 5 and see what I get. I get negative 25 plus 30 minus 9, which is negative 4. And now you can see that the shape of the parabola is forming. With this number of points, I can now pretty well draw what the parabola is going to look like. So I will sketch it looks like this. Okay. Notice my line of symmetry cuts it in half. My maximum point is my vertex. That means that's the highest point on the graph, and it's at 3, 0. So that's a good look at what a parabola looks like. Notice it's going upside down. And the little clue that that is going to go upside down is this little negative sign in front of the x squared. But we'll talk about that more later. Okay, to solve by graphing, we want to find the roots. So here we go. Y equals x squared minus 3x minus 4. First, we're going to find the line of symmetry, then the vertex. We're going to plot a few points, and then we're going to try to pick out the zeros from the graph. Okay, so let's start by finding our line of symmetry, which is minus b over 2a. And you can figure out what a and B and C are here. So we're going to get x equals a negative 3 over 2, which is 3 halves. So that's already yucky because we got to deal with the fraction. But you know what? This is going to be a pretty hard one to graph. So we'll take you through a relatively hard problem, and then it won't seem so hard when you see this kind of problem in the future. Okay? So we found the x value for the line of symmetry is 3 halves. I'm going to go ahead and figure out when we plug in 0 for x for our function, what do we get up here for our function? If we plug in 0, you're going to get 0, 0, minus 0, minus 4. So 0 minus 0 minus 4 is negative 4. Okay, so that's 1 point right there. Now I'm going to plug in that line of symmetry point, that x value that we had just a second ago, 3 halves. I'm going to plug that into our function and see what we get. And I'll get 9/4, that's x squared, minus 9 halves. 3 times 3 halves is minus 9 halves. Minus 4. Again, lots of yucky fractions. But let's go ahead and put them all into the same denominator. So I'm going to get 9/4 minus, 9 halves is the same as 18/4. Minus 4, that would be the same as 16/4. And then I'll subtract those all out, and I'm going to get negative 25/4. Okay, so now I have 2 data points, and I can plot them on my parabola. Now I have to be kind of cautious when I'm thinking about plotting a graph and how I'm going to scale it. So I can see that my x value is going to be 3 halves. My y value is going to be negative 25/4, which is about minus 6 1/4. And so I'm going to go off my graph pretty quickly if I don't scale it in a smart way. So I'm going to scale it so that the x values, every box is going to be an increment of 1 and then 1 and then 1. So 1, 2, 3, and then negative 1, negative 2, negative 3. That's for the x values. But the y value, I'm going to change the scale so that I can fit my parabola in here a little better. So as I'm going down, I'm going to go negative 2, negative 4, negative 6. That way I'll be able to fit the different data points on my graph. And it's okay if the scales for the horizontal axis are different from the x-axis, as long as you label the scales appropriately and you're consistent in your labeling. So I can plot these 2 points. Let's keep going. To plot these 2 points, I got 3 halves over. That's going to be my line of symmetry. So I'll go ahead and plot my line of symmetry. And then my vertex point I figured out was 3 halves comma negative 25/4, or about minus 6 1/4. Okay, so I've just plotted the 1 point, but it was a little bit of work just to figure out how to do the scaling and get it to fit there. Now I don't know where my next point's going to be. Is it going to open up or is it going to open down? So I can plot my other points. For example, I can plot the point 0 over negative 4. So 0, negative 4 is going to be right there. Okay, so that's good. I got 1 point. Now, I need to come up with some other points just to round out the graph to get a sense of what it's going to look like. So I can choose the values of x that help me round out this graph. So I'm going to choose 1 because I like 1. It's a nice, small, easy number. I plug in 1 to my function. I get 1 squared minus 3 minus 4, which is negative 6. And so I can plot that on my graph. Now you get a sense of how it's starting to look. Looks like the graph's going to open up. Now I'm going to go to the right of the line of symmetry and pick some points over there. So let's start with 3 and see what I get. I get 9 minus 4 equals negative 4. So I can plot that point. And I'll go with one more. I'm going to go 4, which is 16 minus 12 minus 4, and gives me 0. Ooh, I got lucky, and so I found one of the zeros. Now I can go ahead and plot the entire graph, and that's what I get. Now I can tell by looking at it that I have a 0 or a root where it crosses the axis. So here's one right there, and it is going to be at 4, 0. And then I can see that I have another one over here, and it looks like, just by eyeballing it, it's at negative 1, 0. So those would be my 2 solutions or roots of this parabola. All right. Now, in some cases, you might not get a real root or real solution. So let's